Hello everyone, this is Vasant, a 9-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to solve some problems on true space and true strain. So this is the first question over here. Accurately, which one of the following are correct if plastic deformations are occurring? So we said accurately. Ex, epsilon x, epsilon y, epsilon z are engineering stresses, and epsilon x plus epsilon y plus epsilon z is equals to epsilon z. First, let us derive the formula. Let us take a cube with x, y, z dimensions, and let us take increasing the dimensions is dx, dy, dz. Then epsilon v change in volumetric strain will be given by x plus dx into y plus dy to z plus dz minus x, y, z initial volume divided by initial volume x, y, z. This is the engineering volumetric strain formula, right? Change in volume divided by original volume. So that will be given by x, y, z into 1 plus dx by x plus 1 plus dy by y into 1 plus dz by z minus 1, right, divided by x, y, z. This cancel. So we get epsilon is equals to 1 plus epsilon x. Dx by x is epsilon x into 1 plus epsilon y into 1 plus epsilon z minus 1, right? So if you expand the terms, you will get 1 plus epsilon x plus epsilon y plus epsilon z plus epsilon x epsilon y epsilon z plus epsilon z epsilon x plus epsilon x epsilon y epsilon z minus 1, right? So this one gets cancelled. So engineering volumetric strain will be given by epsilon x plus epsilon y plus epsilon z plus epsilon x epsilon y plus epsilon y epsilon z plus epsilon z epsilon x plus epsilon x epsilon y epsilon z. Okay, so this is the extra terms. We generally, while calculating the volumetric strain, we assume that epsilon x, epsilon y, epsilon z are very small. So products of these strains will be negligible and they are equals to 0. So by assuming that, we get epsilon v, engineering volumetric strain will be equal to sum of engineering strains. Sorry, we need to write these as strains. These are strains. These are strains. Okay, true strains and engineering strains. So this is wrong, right? Option A is wrong accurately, because we said plastic deformations. In plastic deformations, epsilon x, epsilon y are not too small, so their product is small but not negligible to 0. So now let us move to try to solve second problem. Now we got epsilon v is equals to 1 plus epsilon x, 1 plus epsilon y, and 1 plus epsilon z, right? So minus 1. So we can write it as 1 plus epsilon v will be is equals to 1 plus epsilon x into 1 plus epsilon y into 1 plus epsilon z, right? So apply ln of 1 plus epsilon v will be is equals to ln of 1 plus epsilon x into 1 plus epsilon y into 1 plus epsilon z, right? So this will be is equals to ln of 1 plus epsilon x plus ln of 1 plus epsilon y plus ln of 1 plus epsilon z. So this is ln of 1 plus epsilon v, right? So this will be epsilon v t, true volumetric strain. This will be true engineering longitudinal strain, right? So this is accurately right. So the answer is this one. Okay. So this is about first question. Let us move to second question. This is the second question. Which of the following is are true in case of tensile test? So you took a bar and you are doing tensile test. So if you do a tensile test for ductile material, let us write one answer. So then if we take the diagram of engineering stress and engineering strain will be something like this, right? But the diagram for true stress will be something like this, right? This is true stress because the area will decrease, right? So the true stress will be generally greater than the engineering stress, because from the formula also sigma will be is equal to sigma t of 1 plus epsilon. So see sigma t, this is sigma t. So if epsilon is positive, then sigma t will be greater than sigma for one given E. In tensile test, the epsilon will be positive. So similarly, epsilon t will be is equal to ln of 1 plus epsilon. So it will be greater than 0. So this will be ln of greater than 1, right? Epsilon t, right? So ln 1 will be epsilon greater than that value. So if we see or if we try to solve, so first relation is this one. So first the option should contain this. Okay, this is right, this is wrong, this is wrong, this is right. Now let us move to second part. So now if you see over here, for a given epsilon, for a given sigma, we draw the graph. This one, this one. This will be epsilon t. This will be epsilon. So epsilon t. Right. So this is wrong. This is right. This is right, and this is also right. So answer is D. Do you understand? So if you want to know from here, we need to know the graph of logarithmic function. So the graph of logarithmic function will be so we need to know the graph of logarithmic function and we need to express those and check the graphically, but that is somewhat difficult over here, you can observe. But here if we draw the stress strain diagram for the true stress strain and engineering stress strain diagram, you will get very easily, right? So now let us move to the last question. This is the question over here. So this is of length L. In case A, it is stretched to 2L. In case B, it is compressed to L by 2. Then which of the following are correct? See, first let us calculate case A. Case A में engineering stress epsilon A will be is equals to 2L minus L divided by L. So that will be is equals to L by L is equals to 1. Right? Now epsilon A T will be is equals to ln of 1 plus epsilon A. That will be is equals to ln of 1 plus 1. So that will be ln 2, right? Now let us go to case B. In case B, epsilon B will be is equals to L by 2 minus L divided by L. So that will give us minus half. And epsilon BT will be is equals to L by 2 minus L divided by L. Sorry. ln of 1 plus epsilon B, right? So that will give us epsilon bt ln of 1 plus, so that will be r, right? So epsilon bt will be is equals to minus ln 2 epsilon at will be ln 2. So if you observe the options, epsilon a, mod of epsilon a should be is equals to mod of epsilon b. This is wrong because mod of epsilon a is greater than mod of epsilon b. So there should be this option. So this is also wrong. So this is right and this is right, right? So if you go to the second case, in second case the two stresses are equal. So this is wrong and this is right and this is wrong. This is right. Both options are right in this case, right? So it is clear that in true stress case you are getting the actual picture, right? Whether you compress or you increase, if you are compressing by the same length as you are elongating, then the magnitude of the strain should be same, right? So that is what we are saying by true. That is true. So because we get same true strain, but in case of engineering strain, we are not getting same, as the changing lengths are very large, right? So I think you got the clear picture of true stress and true strain. With this, we end today's lecture. Thank you from ninepointer.